Lesson 2.3.6, Linear Programming. In this video, we will graph solution sets of systems of linear inequalities and label points of intersection on the boundary lines. It is a mouthful, guys, but you've already done it in 3.5. Vocabulary: linear programming. Linear programming is a bunch of mathematics that determines the maximum and minimum values of linear expressions on a region produced by a system of linear inequalities. That is also a mouthful. Graph the solution set for each system of linear inequalities. Label all points of intersection of the boundary lines. So the first two lines on here are the easiest ones to graph. Okay, the first line is x is greater than or equal to 0. So they already have the x-axis, which is x equals 0, and we are shading above it. The second one is y is greater than or equal to 0. It, like the x-axis, the y-axis is that line, and we shade above it, or to the right of it in the positive direction. We don't even need to check 0, 0 on those because 0, 0 is part of those lines. So we shade in the area that is already bound for you. Alright, so the next one here, 4x plus 6y is less than or equal to 72. First of all, it's equal to, so it's solid. And you'll notice that all of the linear programming lines are solid. Okay, so 4x plus 6y is less than or equal to 72. If we check 0, 0, we get 0 plus 0 is less than or equal to 72. So 0 is less than or equal to 72. And this is true. So we're going to shade towards 0, 0, which, by the way, is in the very corner here. Okay, so we'll be shading towards that corner. Because this is in standard form, we're going to go ahead and say 4x is equal to 72 and find our x-intercept. So let's go ahead and divide by 4. So x equals, so that's 18. So our x-intercept is at 18, 0. And then we're going to take 6y equals 72. So we divide by 6, and that means that y is equal to 12. And so our y-intercept is at 0, 12. And we'll go ahead and plot these 2 points. So I have a point on the x-axis at 18. I have a point on the y-axis at 12. And we want to use our straight edge, right, to draw our line. So with our straight edge, we're going to draw a straight line from the y-intercept to the x-intercept. And it's solid again because it was already set to be solid. And then we said that we're shading towards 0, 0. So we'll shade below this line. Okay. The last line is 2x plus 5y is less than or equal to 40. It too is solid. Okay, and if we check 0, 0, we get 0 plus 0 is less than or equal to 40. So 0 is less than or equal to 40 is true. And we'll be shading again towards that corner. So to get our x-intercept, we're going to take 2x equals 40. We'll go ahead and divide by 2 and get x equals 10. So we have a point at 10, 0 is for the x-intercept. Then we're going to take 5y and set it equal to 40. And we'll go ahead and divide by 5 to solve for y. and we get y is equal to 8. So we have an ordered pair of 0, 8 for y-intercept. So we'll go ahead and draw this one on there. X-intercept we said was at 10, y-intercept is at 8, and we're going to go ahead and draw this line. Nope. So math tells me that this here is not right. 40 divided by 2 is 20. So all of you that noticed that and were like, Mr. Sneed, you're doing it wrong. You're right, I'm doing it wrong. So this should have been x equals 20, and we have a point at 20, 0. The y-intercept is correct, but the x was wrong. So let's go back and fix that. Y-intercept is at 8. That one was true, but the x-intercept is at 20, way over here. And then we're going to use our straight edge, and we're going to draw a solid line from the y-intercept to the x-intercept. And then the next part says to label all the points on the boundaries. So we have a point, well actually I guess I should finish that one and shade towards 0, 0. So the area that we are shading is this down here. So now we can label the points on the boundaries. One of the boundary points is here at 18, 0. One of them is here at 0, 8. We have 0, 0 in the corner. And then we have this point here that is at 15, 2. And so those are all the boundary points. So the dreaded moment is here, where I'm going to tell you it's your turn. And you're going to try the next one yourself. Again, remember, you're really only graphing 2 of the 4 lines because 2 of the lines are already there. Okay, so go ahead right now and try number 2 on your own. All right, so hopefully you started by putting hash marks next to the x and y axis. When you took the 2x plus y is less than or equal to 20, you should have found that it has an x-intercept at 10 and a y-intercept at 20. Okay, and again it's solid, and it always 0, 0 works again. So we're shading towards 0, 0. If you haven't caught on, the patterns always shade towards 0, 0 on the linear programming stuff. So we plotted the blue line, right? Put our point at 10 and our other point at 20 and drew a blue line and shaded towards the x-axis, or towards the corner. For the next equation, it also was solid. Its x-intercept was -8 or was 18. Its y-intercept was 12. So we plotted the green line and we shaded below it. And so the area that worked for all of them is that corner area that is like some sort of quadrilateral. And then we labeled our points that are on the boundary. So we have one here at 10, 0. We have the one at 6, 8, one at 0, 12, and one at 0, 0. And that's how we graph solution sets of systems of linear inequalities and label all the points on the intersection of the boundary lines.